This video is going to start chapter 16 of geometry. It's going to cover 16.1 through 16.3. And so we're going to start with 16.1, which is how to go from a conjecture to a proof. And so I have a list of steps here, which are really helpful in the process. So the first thing you want to do so you're given your conjecture and you want to identify what is given to you, because you're going to be given a conjecture and then a set of premises, and then identify what you must show in the conditional statement. So what you must prove, essentially. And then 2, draw and label a diagram to illustrate the given information. Diagrams are essential, especially in geometry, because it's so helpful to visualize the figures and what you're doing. And then 3, restate what is given and what you must show in terms of your diagram. So use your diagram and put in your givens and figure out how you can, with your diagram, find your conclusion. Then plan a proof. So you don't need, this isn't essentially writing a proof, but you need to plan it. And you can do this by organizing your reasoning mentally on paper, just jotting some notes, and then from your plan you can actually write the steps of your proof. So now we're going to do a proof for the triangle sum conjecture. So the conjecture we're trying to prove says that the sum of the measures of the 3 angles of every triangle is 180 degrees. And so our given is just triangle ABC, as you can see here. And what we need to show is that the measure of angle 1, so here, plus the measure of angle 2, plus the measure of angle 3 equals 180 degrees. So now we've done step 1 of our plan. We've kind of identified what we're looking for, and we need to make a plan for how to tackle this proof. So if we draw this line here and call it line BD, we can put point D here and have it be parallel to line A, to segment AC. And then we have angles 4 and 5 up here. Then, so now we can show that this angle here, angle 4 plus angle 2 plus angle 5 is equal to 180 degrees, and angle 1 is going to be equal to angle 4, and angle 3 is going to be equal to angle 5, and then we can show that all of the angles are equal to 180 degrees. So now we can do our proof. So we're going to put our proof down here. And we're going to start out, our first step is draw line BD parallel to segment AC. And the reason for that is the parallel postulate. And then our second step is going to be to say that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is going to equal 180 degrees. And that is by the angle addition postulate and definition of a straight angle. And then our third step is going to be to say that that angle 1 is going to be congruent to angle 4 and angle 3 is going to be congruent to angle 5. And we can say this by the alternate interior angle theorem, which says that if you have 2 parallel lines, then the angles that are alternate and interior are going to be congruent, which means that you'll have 5 congruent to 3 and 4 congruent to 1. And then for step 4, we say that the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 3 is equal to the measure of angle 5. And this is just by the definition of congruent angles. And then our last step is going to be to say that measure of angle 1 plus measure of angle 2 plus the measure of angle 3 is equal to 180 degrees, and that is by the substitution property of equality. And so now we've proved what we were supposed to show here. Okay, so now I'm going to go through a proof of the conjecture that says that the measure of an inscribed angle in a circle equals 1/2 the measure of its intercepted arc when a side of the angle passes through the center of the circle. So we're given circle O with angle MDR on diameter DR, and we're going to show that the measure of angle MDR is equal to 1/2 of the measure of arc MR over here. So here's our proof. I'm just going to go through the steps. So first we're going to prove that segment DO is congruent to segment OM. So we have, and that is for the reason that all radii of a circle are congruent. So now we can say that this segment is congruent to this segment. And then our second one says that then we can conclude that the triangle DOM is isosceles, because now we know that these two sides are congruent, and that's the definition of an isosceles triangle. And then our third one says that angle MDR is going to be equal to angle OMD because of the isosceles triangle theorem, which says that the two angles opposite of the congruent legs of an isosceles triangle are going to be congruent. And now we can say, and we can replace, so here you can see that angle MDR, we can call that X, and we can call angle OMD Z. So we can say that X equals Z. And we can say that X plus Z equals Y because of the triangle exterior angle theorem, which says that an exterior angle to a triangle is equal to the two opposite angles added together. And then for step 5, we can say that X plus X equals Y, and 2X equals Y because of the substitution property, since X equals Z. And then for 6, we can then simplify that to X equals 1/2 Y, and that's the division property of equality. Then for step 7, we can say that the measure of angle MDR is equal to 1/2 the measure of angle ROM, and that's through the substitution property, because angle ROM is going to be angle Y. So we're just saying again that X equals 1/2 Y, but we're using the actual angle measures. Then for 8, we can say that the measure of angle ROM is equal to the measure of arc MR. And this is because the measure of a minor arc is equal to the measure of its determined central angle, and we can see that Y is going to be the central angle for this arc. And then our final step, we use substitution to say that then the measure of angle MDR is going to be 1/2 of the measure of arc MR. So we have just one vocab term here. A corollary occurs when a conjecture can be proved as an immediate consequence of another theorem. So then it's a corollary of the original theorem.